a review of trigonometry. So let's start off with that. Trigonometry. Now, the first part of trigonometry, and what it's used for, is to solve angles and sides in right-angled triangles. Okay, so trigonometry is a little bit more advanced. Typically, in fact always, it uses angles to solve these sides, or you can use sides to solve angles. So that's how you know when to use Pythagoras. You only see sides, whereas trigonometry you can use when you see an angle as well, or you want to solve for an angle. Now, to start off, it's all about labeling the sides. So what I'm going to do, add this diagram here, and we're going to label the sides of this diagram. There's also going to be one over here, which is a your turn for you to practice. Now, to start off with, we've got to learn a new letter. This letter is called theta, and it's just like an unknown, right? So it's a Greek letter, and typically it's used for angles. Now, there's three sides we've got to know about, and then we've got theta. So you've got h, which is the hypotenuse. Then you've got O, which is the opposite. And then you've got A, which is the adjacent. Now you may connect these with before. These are the shorter sides. Okay, remember with Pythag, A and B were the shorter sides. This is very similar, but it's done from the perspective of the angle. Okay, so from the point of view of theta. So we always are looking from theta going, which one's the opposite? Which one's the adjacent? So let's go and label this triangle now. So we start off here, we've got our theta and we've got our right angle here. The hypotenuse is the one I always start off with. It's always opposite the right angle. So I'm going to label this with H. That's the hypotenuse. Next, let's do opposite. Okay, so the opposite here is, we start from our theta there, it's opposite the theta, the side that's opposite the theta. We can see over here that this side here is opposite the theta. The last one is adjacent. Now adjacent means next to, so being next to something. So we can see that this side here is next to the theta. So it's the shorter side that's next to theta. So we're going to label that A. What I'd like you to have a go at now is labeling this triangle over here. So press pause, do that, and then press play when you're ready to go. We're going to go through the answers now. So what you should have is H here, opposite the right. You should have O here and A here. Well done if you've got all of that. If you don't know how to do that, make sure you get on top of that first. Otherwise, trigonometry is very difficult without that skill. Let's move on. We're going to looking at the three trig functions. So we've got sine, cosine, and tangent. Okay, now these three trig functions, they're chosen based on what situation you have. Okay, so they help us find lengths and angles. Okay, and we choose either sine, cosine, and tangent based on what we know and want to find out. Okay, so let's go through what sine, cosine, and tangent stands for. Now you may remember this saying, so, ka, toa. Okay. Now this here helps us remember, it's called a mnemonic, it helps us remember what each one stands for. So sine, S is for sine, theta. Always feed each trig function an angle. C is cosine, give it an angle, equals. And T is tangent, give it an angle, theta. Next, we've got our numerators. And then next, we have our denominators. Now this here is a helpful way of remembering all these functions, and we choose sine, cosine, or tangent based on what we know or want to find out. For instance, we use sine if we care about opposites and hypotenuse, or we don't care about adjacents. We use cosine when we care about adjacents and hypotenuse, i.e. we don't care about opposites, and we use tangent when we care about opposites and adjacents, i.e. we don't care about the adjacent side. So with that in mind, we're going to solve some triangles. You ready? Let's go. So this one here is case number 1. Finding unknown sides when they are a numerator. Okay, now what I'm going to do is I'm going to add 3 triangles on this diagram. This one here is going to be my triangle, and then I want you to have a go at these triangles to the right to see if you've got this skill down pat. Okay, so let's get cracking. So we're going to have a go at the one on the left here. First step is we've got to label the sides. Second step, we choose the rule. Third step, we solve. So let's label the triangles. So we've got H, O, and A. That's how we label. So which one's the hypotenuse? It's the hypotenuse because it's opposite the right angle. Now, what's the opposite side? Well, here is our angle theta. So what's opposite the angle theta? Remember, we always go from the point of view of theta. Here it is. The next one is the adjacent. Now, do you see here how this side is blank? I'm just going to basically ignore adjacent, okay? We only care about, in this case, the opposite, because that's what we want to find, and the hypotenuse, because that's what we found. Adjacent, we're just going to ignore, as there's no information there. So, what trig function uses O and H? So, ka, toa. Well, we know that it's so, because that uses O and H. Next step, write out that. Equation, sine theta is equal to opposite on hypotenuse. That equation has to just come out as soon as you say so, you should be able to make that equation. Next is we're going to solve by subbing in our values. So first thing, we know that the theta is 35 degrees. Opposite is x, and the hypotenuse is 12. Do you see here, we're just subbing in those values. Next is we want to get x by itself, times both sides by 12, because this side over here is essentially dividing by 12. The opposite of dividing by 12 is timesing by 12. What we do to one term, we do to all the terms. So now we've got this. 12 times by sine 35 degrees is equal to x. Let's type it in and see what we get. 12 times by sine 35 degrees. And we get 6.88 millimeters. Now, do you see I've added my units there? Just make sure that you add your units and 2dp. So now hopefully you've got to grips with that. Have a go at these two on the right. Then, when you think you've got it, press play and go through the answers. Okay, so for this one here, you should label. You've got hypotenuse here and an adjacent here. So we're going to use ca. We write out the rule. Cosine theta, adjacent on hypotenuse, sub in. Rearrange. We find our answer of 6.69 centimeters. Next, we use our we label. So we've got an opposite here, an adjacent here. Then we know what uses that, TOA. So therefore we're going to write our equation. Tan theta is equal to opposite on adjacent. We sub in. Rearrange. And then we find our answer of, and I should have it over here, 6.25, and our units are millimeters there. Now, I hope that you've got on top of case 1, finding unknown sides when it's a numerator. Okay, now we're going to stop it here. In the next video, we're going to be looking at cases 2 and cases 3, finding unknown sides for a denominator and finding unknown angles. Thanks.